Okay folks, so that's going to wrap up the build. We're all set. But what I wanted to go over with real quick was just a few of the things when you fly this, what to look for and why this is an improvement over the 7HP head. So I've seen some questions about, what's the big deal about changing geometry and things like that. So I wanted to just kind of go over an overview of the differences in the head design itself. So the first thing that I want to show is the flybarless drivers. On the old 7HV, these were brought in. The swash was a smaller diameter, and the holes are brought in, and they made an angle there. Now they are straight up and down, so when you're at zero pitch, it's a parallel to the main shaft. What that means is when the swash tilts 15 degrees, the blade angle changes exactly 15 degrees essentially. So it's about a 1-to-1 ratio. So what that does is provide a very linear response on the pitch changes from the swash. Next on the swash is the location of the outer balls. The inner ones are increased in diameter, and also the outer ones are increased. It's a much larger swash than the original one, as shown in the earlier video. And what this is going to do is it adds a mechanical advantage, and it also increases the resolution. At 15 millimeter spacing, the arm is out farther than the ball here, so the link is angled farther to the left at the bottom and farther to the right as it goes to the swash. Now what this does is at zero pitch, when it's angled like that, when you move the servo up, it's now approaching more of a vertical angle. So now at this point, it's a much more linear response. Being straight up and down, you're going to get more lift of the swash for less travel of the servo. So what this does essentially is to help minimize that initial hit to make it more linear across a broader pitch range, so that when you decrease or increase pitch, the links become more efficient in their travel again until you get to the ends, so that overall you get a much more linear feel. Okay, so at the end of the day, what does that all mean for us? Well, after flying, I gotta say that the linear feel is incredible. It's a night and day difference between the 7HV and the Chronos. It really is. Now the 7HV flew very well, but the Chronos is just that much better. It feels light. It's the best way to describe it. It flies like it's about a pound lighter, but yet it's not floaty. It's still just as precise and has the inertia that a 700 class helicopter has, but it's just very, very fluid. To be honest, it's very much like a sim. And again, one of the reasons is the geometry, and the other one is the main shaft is just, it's obviously a lot thicker, it's beefier, and you're going to get fewer vibrations, and there's absolutely no flexing going to go on inside there. That just helps stiffen up the whole frame. The frame stiffeners that we went on and installed, again, it just helps draw everything up so it's very tight. So what happens is any movement in your servos is relayed directly to the blades, and it's not lost in inefficiencies and things moving or bending or flexing or anything like that. So it's a very direct response. I run the Spartan, and my numbers are really good, just a little bit over 100% for 14 degrees of pitch and about 12 degrees of cyclics, where I kind of like it. And if you have a servo arm that's longer than the 15 millimeters, you might want to trim the extra away if you can, because when this goes all the way down, the ends that stick out too far can actually go ahead and touch up against the frame. So just pay attention to that when you're checking your extremes. If you guys are using flybarless units that have a artificial, like a pitch pump enhancement for collective, turn it down or shut it off. In fact, I leave it at 0 for now, at least until you fly it. When you're making collective changes, the helicopter just bites and goes. It doesn't make big barks and flappy noises in the blades, it just moves. It's very efficient in its change of direction. It's very, very stable in fast forward flight. The 7HV always was. Not a whole lot new there. It's very impressive. What you do pick up is when you change directions suddenly, abrupt stops, if you do a wall, if you do a flip while you're traveling at a high rate of speed. When it's loaded is when I really notice the difference. It doesn't have any adverse tendencies. It stays in composure. I did some nasty TikToks to try to work on my 12-point TikToks, which get kind of sloppy. And it just takes it in stride. The 1 millimeter gap in the head button, I still suggest. I flew at 1800, did a little around 1750, and then at the same setting I went up to 2100 and flew around and just tried to get ugly with the sticks, and it just worked fine for that. So that is a good range to use, definitely to start out with. Feel free to loosen it or tighten it depending. If you fly faster than what I use, then go ahead and just try to tighten it down. What can happen is it can get a little, I don't know what you'd call it, stodgy, a little more hesitant in direction changes. Might lose a little of that natural kind of a feel, but just something to play with. It's going to depend on your blades. I'm running the Cyclone blades now. My main issue with these before on the 7HV was I didn't get as much pop as with like the Compass blades, but they were very efficient. And now the collective is just spot on. It's very quick. So they definitely made these blades fit this helicopter a lot better. And then to sum up with all the changes, it's now just incorporated all the improvements done to the tail that made that bulletproof, and now applied basically that same philosophy to the head and beefing everything else up. It's just very robust. It's a complete package. But then that's about it, folks. So definitely enjoy. If you have any questions, definitely reach out. It's been a pleasure making this vid for you guys. I do hope you enjoy it. Any other questions, just go ahead and let me know. Enjoy your build and enjoy the hobby. Thanks, guys.